All right, you guys, so we did transforming random variables where you can multiply and add. Now we're going to do combining random variables when you have more than one random variable. So to find the mean of the sum of random variables, it's pretty easy for any two random variables x and y, and we want to find the total of x and y. The expected value, also known as the mean, is mu of x plus mu of y. So you just add the means together. That's combining them. So let's go back to the Jeep problem. So earlier we examined the probability distribution of the random variable x, which is the number of passengers on a randomly selected half-day trip with Pete's Jeep Tours. And here's a brief recap. All right, so by the way, how do they get this number 3.75 for the mean? Yeah, we do this times this plus this times this plus this times this plus this times this plus this times this, right? Don't forget that formula for expected value. And then for the standard deviation, do you guys remember the formula? You take the number minus the mean squared times probability plus the number minus the mean squared times its probability plus the next number minus the mean squared times its probability, and then you do what at the very end? You square root the whole entire thing. All right. Good review right there. Well, now Pete's sister, Erin, wants to join in the business. She also lives near a tourist area in another part of the country, and she's impressed by the success of Pete's business, so she decides to join in, running tours on the same days as Pete in her slightly smaller vehicle under the name Erin's Adventures. After a year of study bookings, Erin discovers that the number of passengers Y on her half-day tour has the following probability distribution, and there's her information. So if we want to find the expected value of the total, okay, the expected value of both of these, first of all, what's the range of Pete's Jeep Tours? What's the range of passengers? Yeah, he can have 2 to 6 people in his car. And what's the range of Erin's? 2 to 5. So what's the range of the total number of passengers? 4 to 11. All right? The smallest sum, we add them together, is 4, and the highest one is 11. So if I was going to find the mean, we could have 4, we could have 5, we could have 6, 7, 8, 9, 10, or 11. There's the total number of passengers we could have between the two tours, right? And how would we find the probabilities? Well, what's the probability of getting a 2 and a 2? It would be 0.15 times 0.3. 0.15 times 0.3. And then what's the probability of getting 5? Well, we could have a 3 and a 2, right? That's 0.25 times 0.3. Or we could have a 2 and a 3, which is 0.15 times 0.4. Right? And we could find each probability. This would take a while, right? We'd have to do every combination of 6, every combination of 7, every combination of 8, and then we'd have to do the formula for expected value of the total, right? Or we can do the super easy way, which would be to do what, you guys? What I wrote right here. Oh, let's just add the means. That's way easier, right? So instead of actually calculating it out with all the probabilities, well, they already found the mean of this guy, 3.75. And we're going to add it to the mean of this guy, 3.10. Those are the mean number of passengers on any given day. Add them together, and we get 6.85. There's the average number of passengers between both of them. Okay? So do it the easy way and just add the means. Makes more sense. A lot faster. So we just did that. All right. How much variability is there in the total number of passengers who go on Pete's and Aaron's tours on a randomly selected day? Well, we can do the range, which we just talked about, was 4 to 11. But what about the variance and the standard deviation? Now, the variance, you can go ahead and just add. So write this formula down. Sigma squared of t, so that's the variance. When it's sigma squared, that's variance, of the total is equal to sigma squared of x plus sigma squared of y. Oftentimes, they're not going to ask for the variance. They're going to ask for the standard deviation. Okay, helpful hint. This is not legal. Don't ever do it. All right? You can't just add the standard deviations. It's not allowed. All right? What you can add is the variances. And if you can add the variances, can you then find the standard deviation? Yes. So I can square root both sides, right? So in order to find standard deviation, it is always equal to the square root of the variance of x plus the variance of y. So add the variances and then square root it, always, to get your standard deviation. All right, and side note, they must be independent. All right, in order to calculate variance, you must have independent random variables. What does independent mean? If you know the outcome of the first event, it does not affect the outcome of the second event. So think of sampling with replacement. Okay, those would be independent events. Let's go back and actually calculate this on our problemo here. All right, so if I want to find standard deviation of the total, notice they gave us the standard deviation here. When you plug it into the formula, you are going to have to square it. 1.0897 squared plus the standard deviation of y, 0.943 squared. All right, so that's how we find the standard deviation. Plug them in. You got to square them first if they're giving you standard deviations, and then add, then square root them, and you can get the standard deviation of the total, which is 1.441. Now, be sure you know how to interpret these. What are we even talking about? What does that 1.441 represent? Jordan, what do you think? Yep, of the sum of the passengers, right? And what does standard deviation mean? Yep, typical distance from the mean. So our mean was 6.85, right? Which was the average number of passengers of both tours. So this would be the typical difference, or how much we're typically off from the mean. We're going to be off by about 1.4 passengers, okay? All right, so a college uses SAT scores as one of the criterion for admissions. Experience has shown that the distribution of SAT scores among its entire population of applicants is, they give you the math score, and then they give you the reading score. What is the mean and standard deviation of the total score, x plus y, for the randomly selected applicant to this college? All right, so I want to find the total score, the math plus the reading. Mitch, how am I going to find the mean of the total score? Yeah, that's it. Okay, add those together and get your total. All right, now to find the standard deviation, the formula is the square root of the first guy squared plus the second guy squared, right? However, are these independent events? And this one's kind of tricky. But they're actually not. Because typically, if you do well in math, you also do well in reading, according to this. All right? So, if they are not independent, you cannot calculate the standard deviation. All right? So the variance and standard deviation of the total cannot be computed from the information given. SAT math and critical reading scores are not independent. Students who score high on one exam tend to score high on the other. All right? So let's see. Now we're going to add in a couple extra things. So our transforming random variables and combining at the same time. So we're going to use what we learned last week, if you remember, and then what we just learned today. So earlier we defined X as the number of passengers that Pete has and Y as the number of passengers that Aaron has on any randomly selected day. And there's our mean and standard deviation for Pete is X and Aaron is Y. Pete charges $150 per passenger, and Aaron charges $175 per passenger. Calculate the mean and standard deviation of the total amount that Pete and Aaron collect on a randomly selected day. So I want the total, but this time of the amount of money that we collect. Anyone have an idea as to how I can do that? Okay, close?
And then the other one.
Perfect. So this Pete, he makes $150 per passenger, so he's going to be $150 times 3.75. That's the average amount he's going to make, right? $150 per passenger. And then Aaron charges $175 and has an average of 3.1 passengers. So we both multiply each of those and add to give us a total amount of money that they make combined, which is $1,105. Okay, and are these events independent? Yes. Number of passengers on one person's tour does not affect the number of passengers on the other. So we can calculate the standard deviation. And this time it's the standard deviation of the money. So our formula is the square root of the variance plus the variance. So do I multiply, you guys, this 150 times the standard deviation? Yes. We do not add or subtract, right? We only multiply. So we're still finding an average distance in the amount of money, which means you do multiply by 150 to get that standard deviation. So in parentheses, I have 150 times 1.0897, and I have to square this whole thing, plus. Same thing here, 175 times 0.943 squared. All right, so you go ahead and multiply them because you are allowed to do that. And then you square your to get your variances, add them together, square root, and we get 232.28. So in other words, typical amount of money we make, $1,105 combined. And then the typical distance or amount we're going to be off is 232.28. That's it. Let's try one more and really make sure we got this. A large auto dealership keeps tracks of sales and lease agreements, so we kind of did this one before. Made during each hour of the day, let X be the number of cars sold, but now we're also adding in Y, which is the number of cars leased during the first hour of business on a randomly selected Friday. Based on previous records, the probability distribution of X and Y are as follows. Define T as X plus Y. Number of cars sold plus number of cars leased. Assume that X and Y are independent. Find and interpret mu of T. So, Cody, how do I find mu of T? Exactly. Add the means together, and that gives us our typical number of cars leased or sold on any given Friday. Okay, be sure you interpret these when they say interpret. All right? Compute sigma t. So that's our standard deviation. So Molly, what would I do to compute our standard deviation? Good. Don't do separate square roots, but yeah, one big square root over the sum. And yes, then you got it. They are independent, so you are allowed to do that. And we get 1.14, which is how much we're going to be off from the mean number of cars. All right, so now we'll add in transforming them. So the dealership manager receives a $500 bonus for each car sold and a $300 bonus for each car leased. All right, so they're different. Find the mean and standard deviation of the manager's total bonus. So Elizabeth, how would I find just the mean if I get 500 per car and 300 per lease? Yep. Exactly. Okay, multiply each of the means, add them together. And then standard deviation, Mac, what would the formula be to find the standard deviation of the amount in our bonuses? What? I'll help you out. Square root. You have to go back to the separate ones. Those two numbers, these guys right here. And I have to multiply them each separately, right? So 0.943, what am I going to multiply that one by? Good. And put it in parentheses. 500 times 0.943, and then square it. And what's the next one going to be? Okay. 300 times 0.64 squared. Okay. And that's our formula for standard deviation, which gives us 509.09. Any questions on that, you guys? That's it.